Welcome. This video is going to go through solutions to both paper 1 and paper 2 questions over equilibrium. So question number 1 says, which statement about chemical equilibria implies they are dynamic? So the word dynamic means that it's not static, it's not at a standstill. So A, the position of equilibrium constantly changes. That would be dynamic, but it's not true. The word equilibrium means balanced. The rates of forward and backward reactions change, and again, that would be dynamic, but it's not true because it doesn't mean they're at equilibrium or balance. Reactants and products continue to react. Yes, that's true. They happen to continue to react at the same rate. So as fast as reactant is colliding and making product, other product is colliding and making reactant. The concentrations of reactants and products continue to change. Now, the concentrations remain the same because of the balance between the forward and reverse reactions. So C is the only true statement for number 1. Number 2, the sequence of diagrams represents the system as time passes for gas phase, and you see that X and Y are represented by the shaded circles and the non-shaded circles. So when you start, you have only X. So you have all reactant. Diagram 2, you have some product. And then diagram 3 and 4, you have the same amount of product and reactant. So at diagram 3, this is apparently where you've reached equilibrium because there's no change in concentration when you get to diagram 4. So which statement is correct? At T equals 5, the rate of forward reaction is greater than the rate of the backward reaction. And we have no evidence of that. It appears that the rates are the same because they haven't changed from diagram 3 to 4. B, at T equals 7 seconds, that's the beginning, the reaction has reached completion. That's false because it hasn't even made any product yet, so that's before it's begun. C, at T equals 10 minutes, the system has reached a system of equilibrium. That appears to be true because 5 days later, there's still been no change in concentrations. And D, at T equals 5 days, the rate of the forward reaction is less than the rate of the backward. And again, that doesn't appear to be the case. They appear to be equal. Number 3, what's the equilibrium constant expression? So it's going to be product over reactants. That means I'm going to have NO2 on the top, which all except D at least sets up a ratio. And then since there's a coefficient of 2, that lets me know it has to be NO2 squared. So it appears B is my only plausible answer. And when I look at the bottom, it should be over the concentration of N2O4. So B would be my correct choice. Number 4, an increase in temperature increases the amount of chlorine. So an increase in temp is going to increase my yield or my product. So that means increasing temperature must be like adding a reactant, because increasing means I'm either adding a reactant or product, and since product increases, it must be added to the opposite side. So what's the best explanation for it? The higher temperature increases the rate of the forward reaction only. No, temperature is going to increase the rate of both reactions. It's going to favor one more over the other. Both rates are going to increase, but one direction, the heat is actually going to increase the number of successful collisions, and on the other side, it's going to decrease the number of successful collisions, or at least not increase it as much. B, the higher temperature increases the rate of the reverse reaction, and again, that's not true. It's increasing the rate of both. C, the higher temperature increases the rate of both reactions, but the forward reaction is affected more than the reverse. That is true. And the higher temperature increases the rate of both, but the reverse reaction is affected more than the forward. So I would go with C, that the forward reaction is affected more than the reverse. The increase in collisions is greater on the forward side. Number 5, what effect will an increase in temperature have on the Kc value? So I see that enthalpy is a negative. So if I increase temperature, it's going to be like adding a product. And when I add a product, that should drive the position of the equilibrium left. And because it's temperature changing, that will affect Kc. And since Kc is going to have a smaller number on top and a bigger number on bottom, that would mean Kc should decrease. So if I look for the descriptor that fits this, I would see that B indicates a decrease in Kc with a shift to the left in equilibrium position. Number 6, the equilibrium between nitrogen dioxide and dinitrogen tetroxide is shown below. What happens when the volume of a mixture at equilibrium is decreased? So when volume decreases, pressure increases. And this would affect the more crowded side. And I do happen to have a more crowded side on the reactant side because I have 2 moles of gas versus 1 mole. So the increase in pressure is going to cause more collisions on the reactant side, which is going to cause an increase in the concentration of product made. However, it's not going to affect the Kc value. So down below, the value of Kc increases. That's not true. Only temperature will change the actual Kc value. B, more N2O4 is formed. That's true. It's going to be driving it right. And 3, this one's a little bit tricky, but you realize either 1 or 3 has to be true along with number 2, just because of the way the choices are organized. It says the ratio of NO2 to N2O4 decreases. That's true. The amount of reactant over product is going to decrease even though Kc stays the same, because remember, Kc isn't just the concentrations. It's going to be N2O4 over NO2 squared. So that's how Kc can remain the same even though this ratio does indeed decrease. So C, 2 and 3 are both true. Number 7, consider the following equilibrium reaction. What change in conditions will increase the amount of SO3 present? So since it's negative, I'm going to think of heat as a product. Decreasing the concentration of SO2, so a decrease on this side would pull the reaction left. So that would not increase the amount. Increasing the volume is going to decrease the pressure, and I've got 3 moles versus 2 moles. So decreasing the pressure would cause fewer collisions on the reactant side. So again, that's going to shift it left, not right. So increasing the volume is not going to help. Decreasing the temperature is going to be like removing a product, and that would increase SO3. And D, adding a catalyst, that's only rate that's going to be affected. So C is my best choice. Number 8, what will happen when at a constant temperature more iodine ions, so the iodine ions are right here, are added to the equilibrium below? So I'm adding a reactant. It says the amount of solid iodine decreases and the equilibrium constant increases. Well, because I haven't changed temperature, Kc is not going to be affected. So if I look through, A and C aren't plausible. So B says the amount of solid iodine decreases and equilibrium constant remains unchanged. That would seem true because I have more I minus, and so it's going to collide more with the other reactant. And D, the amount of solid iodine increases. No, it's going to be used up more. So B is my best choice. Number 9, what changes occur when the temperature is increased in the following at equilibrium? And since I have a positive enthalpy, heat is a reactant. So if I increase temperature, I'm adding a reactant, which means I'm going to shift the equilibrium toward the products or to the right. And the value of my equilibrium constant then, since it's product over reactant, is going to increase. So the one that matches this would be D.